Hi! An intelligent light bulb can deliver more than 16 million colors combining the luminance of its LEDs, but which is the combination that delivers the highest color rendering index? Which is the combination if we want to boost our performance while maintaining energy efficiency?
In today's video, we will see how to create a fixture with different light scenarios using Kumux, a new light simulation software where a user can create custom and optimized scenes using LEDs from the market. Precisely, we will create an advanced tunable white system with enhanced melanopic and colorimetric properties that contains 3 different scenes. Let's start! Once we have signed into the platform, we are going to create a new fixture called Awesome Tunable White that is going to have 5 different channels. The first channel will be composed by LEDs of 2200 kelvins with an energy efficiency of at least 150 lumens per watt. We can click this icon to see the properties of the LED and then drag the LED to the PCB space. Now we select the number of LEDs connected in series and parallel in the PCB and set the electrical current that the driver is going to deliver to this particular channel. The second channel will be composed by LEDs of 6500 kelvins. Once again, we can see the properties clicking the icon. The configuration will be the same as before. We repeat this process using red, green lime and blue LEDs to complete the composition of the PCB board. Red LEDs are important to keep a high color rendering index, while the lime LEDs are going to have an important impact in purity and keep the energy efficiency high. Finally, blue LEDs with a peak at 470 nanometers are going to provide a strong melanopic flux at high CCTs. The algorithms developed by Kumux can handle a lot of different color combinations, so we will be able to choose the best spectrum for our needs. The possibilities are endless, but in this video we are going to create 3 different scenes. One colorimetric enhanced spectrum, where the extended CRI and R9 values will be much higher than the white LEDs of the PCB. A daylight spectrum with a high color rendering index and a high melanopic flux, and finally a nightlight spectrum with a moderate warm CCT but a very low melanopic flux. Now, the algorithms are working hard, so we will have to wait a few minutes. Once the simulation is finished, we click on the View Simulation button. The simulation window is loaded and here we will find the LEDs we have chosen before, the safety scenes and the results of our simulation. The sum of all the generated spectra of the simulation and their location into the colorimetric diagram is presented in these 2 charts. We can filter the results using the toggles or use the sliders. In these sliders we can see the minimum and maximum values of the colorimetric, non-visual and power parameters. On the bottom, we will see the general charts containing information about the possibilities of the simulation. Now, let's create the first scene. The first scene is going to have a middle CCT between 3500 and 4000 kelvins. The evolution of the filters can be seen at the colorimetric diagram. We select the highest CRI and R9 values available, so we end up with one just combination left. We name this combination High CRI and save the scene created. A new window pops up with all the colorimetric, non-visual and power information related. Now, let's create the second scene. The second scene is going to have a daylight spectrum. To do so, we set the minimum MDER to 1. MDER is the melanopic daylight efficacy ratio, and it is a measure of how the light affects to our circadian system in comparison to the D65 standard illuminant. Then we set the CRI at a minimum of 90 and we get the CCT around 6500 kelvins. Now we can save the scene and see the generated report. Finally, we are going to create a nightlight. It is important to preserve a minimum energy efficiency of 150 lumens per watt, because we assume that this light is going to be on a high amount of time. We want the CRI above 80, so we click the toggle to set it up fast. Then, we select a minimum CCT of 2700 kelvins, and finally we minimize the melanopic photopic ratio. we can see the position of the last combination left, which is far away of the Planckian locus. As usual, we save the scene and get the report. Once we have created all the scenes we want, we can export the results using the export button. A comma-separated value is going to be downloaded, so we can export the scenes to a fixture that contains the LEDs of the PCB we have created.
Well, that's all for today. If you have any questions or you want to try the software, please contact us. Thanks for watching.